This morning in the Atlanta airport, no one's missing a meal on Mac Wilburn's watch. With 11 restaurants to serve passengers, he's got dining for every destination. And it all started when Mac talked with First Horizon Bank about opening a franchise in the airport. Now it's open for business and cleared for takeoff. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac. First Horizon Bank, member FDIC.
Well, shopping for a car?
Yep, Carvana made financing a car as smooth as can be.
Oh, yeah?
I got pre-qualified instantly and had real terms personalized just for me.
Doesn't get much smoother than that.
Well, I got to browse thousands of car options on Carvana, all within my budget.
Doesn't get much smoother than that.
It does. I actually wanted a car that seemed out of my range, but I was able to add a cosigner and found my dream car.
It doesn't get much...
Oh, it gets smoother. It's getting delivered tomorrow.
Visit Carvana.com or download the app to get pre-qualified today.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the astronomy podcast known as Space Nuts with me, Andrew Dunkley. And joining me, as always, is Fred Watson from the Australian Astronomical Observatory. Hello, Fred.
Hi, Andrew. How are you going?
I'm
good to
well.
Be talking again.
Yeah, it's good to talk to you too. It seems like ages.
Oh, it does. I know it does. Can't be more than a week, though, really, can it?
Well, as they say, a week's a long time in politics.
And space science.
And
yes.
space science, yes.
Yeah.
Now, today we've got a few things on the boil. We're going to talk about Elon Musk. This bloke impresses me beyond my wildest dreams. And you know, he's so famous now, he's doing cameos in movies. I mean, this guy is awesome. And I think if he ran for president, he'd win.
Well, that's not hard, is it? Really?
No, probably not. Now that we've seen what's happened in the last 12 months or so.
Never mind. No,
not going there,
Never mind.
We're going to talk about his new spacesuit, which is why he's in the news at the moment. We're also going to look at ESO's very large telescope interferometer.
Yeah, that's
great. What it's up to. That was a lucky guess. And questions from the audience. We've had a question from a fella named Rob Scott in Coolum in Queensland, Fred, and he's really keen for this answer. I think he's followed us up a couple of times. We'll tell you a trade secret, Rob. We actually haven't done this for well over a month. So this is our first opportunity to answer your question. So let's get on to that a little later. But first, Fred, Elon Musk.
Indeed, Elon Musk, not only now famous for Tesla cars and big batteries and SpaceX, but also for entering the future fashion world of spacesuits.
Yes.
So that's why he's been in the news recently. I mean, SpaceX is really continuing in a very satisfactory way. All their work on these reusable first stage rockets is going to plan, and so I think they are on track for their target of using their Falcon rocket to get astronauts up and down to the International Space Station within about a year. Sometime next year is when they're planning the first crewed flights to the space station. Because, of course, today they've just had unmanned capsules, which have been full of cargo and things like that.
And just to clarify, crewed as in CREWED, not crude.
No, well, you know, I think the other word works perfectly well too. But yes, you're quite right. It's crude. I mean, it's because we can't say manned anymore.
No,
that's why.
And person sounds so
person just
ridiculous.
sounds, yes. Yeah. Anyway, crude capsules full of hopefully not crude people will be going up and down. And so I guess the spacesuit that Elon Musk unveiled a couple of weeks ago is really part and parcel of that project. It's to provide apparel for people who will fly on the Falcon capsule up into space. As far as I know, that's its primary use. Of course, Elon Musk is also in the business of promoting space tourism, and it may well be that becomes part of what you get when you go as a space tourist with SpaceX. You get one of these spacesuits. But the interesting thing about it is that it's not just the kind of scientific a masterpiece that you would expect a spacesuit to be, because it's got to withstand the most arduous conditions in space of vacuum and radiation and all the rest of it, zero gravity. That's all in there. That it not only does that, but it looks really good as well.
Oh, it's a stunning piece of engineering. Let's call it engineering, because that's what it is. That helmet, if you were on a motorbike with that helmet on, you'd get a lot of double takes.
Yeah, you probably get booked as well.
Maybe.
But, the reason is that, it's not accidental that this thing looks sensational, because Elon Musk has hired a movie costume designer.
Of course he
to
has.
look at the overall shape, a man called Jose Fernandez. And he apparently designed, the outfits that people wore on things like Spider-Man and Batman and Wonder Woman. He designed all that. Wow. And now he's designed Elon Musk Man or whatever, woman. So
the man of Musk.
This is the man. Yeah, well, that's right. That could be a winner, that. Anyway, but it's very, very stylish. When you put it on, well, I haven't done that, but when you put it on, it looks as though it's very purposeful. And actually, there's a lovely quote from Jose Fernandez. And he says, Mr. Musk wanted it to look stylish. It had to be practical, but also needed to look great. When people put this spacesuit on, he wants them to look better than they did without it, like a tux. You look heroic in it. What a great idea. I mean, look, given that the visor covers your face entirely, it's probably not that hard to look better with the spacesuit on than
fair point.
Without it.
Yes.
But I think Mr. Fernandez's point is very much that it is in a different universe from the spacesuits that were used when Neil Armstrong and Buzz Aldrin walked on the moon, which were kind of related to the Michelin Man advert.
That's right. I've actually seen Neil Armstrong's suit close up. It was in a glass case, but I got that close to it and had a look, and yeah, they look rather prehistoric compared to even the modern standard spacesuits that you see.
That's right. It's not the same as putting on a tux.
Absolutely
it doesn't
not.
have the same classy effect. As Elon Musk is at pains to point out, when he released these images of his SpaceX spacesuit, he said it's not just a mock-up; it actually works. It's been tested.
And I would imagine, Fred, that it's not just about going into 7-Eleven and buying a T-shirt. These things have to, as you said, withstand some amazing conditions. But I would also suggest that the engineering that goes into a spacesuit is pretty heavy-duty stuff. You've got to meet certain parameters and make sure that there are safety issues that are met.
Of course, and I think the reason why these things don't look like the old Apollo era spacesuits is because technology has moved on so much in that last 50 years or so. It's nearly 50 years. There are new fabrics, new materials, new knowledge really about the environment of space. All of that contributes to the ability to make something that is not just functional, but sensationally appealing in its appearance. So I think, there's going to be many photo opportunities for astronauts wearing these things, because, of course, one of the other attributes of our modern era compared with the 1960s is that there are TV cameras everywhere. So inside of spaceships, inside the International Space Station, everywhere. So there are many, many opportunities for future astronauts wearing the SpaceX spacesuit to look sensational on TV.
Indeed. I can see one major positive and one major negative with these suits, Fred. The positive is that, comparing it to a tux, you don't have to use a bow tie, so you don't have to learn to tie one. The negative is Elon Musk, as powerful as he is, still wouldn't be able to wear one into a bank.
No, I don't think so. I think you with these suits, you have to choose your time and place. There are places where you could not wear one. That's true. And maybe a bank is one of them.
I think it would be, yes.
Yeah.
All right. Keep an eye out for it. And, if the day comes where you get to wear one, lucky you. You're listening to Space Nuts with Andrew Dunkley and, of course, Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, we're off to a place called Antares. This is a star that has been the focal point of the Very Large Telescope's interferometer. And that's all I can tell you. Why? Why is this so interesting?
Well, it is. I think this is one of the great stories of well, certainly this week and probably last week as well, in terms of the achievements that astronomers are actually arriving at these days. So let me take you back to the most rudimentary kind of stargazing. If you stand outside and look at the stars on a dark night, and you can certainly do that where you are in Dubbo, less so in the cities of the world because of light pollution, but never mind. You can still usually see the odd star or so. What you see is points of light. And then when you get enthusiastic about this and tell somebody you want to have a look through a telescope, you point your telescope at the stars.
Let me guess. And you see points of light.
Points of light, yes, exactly.
That's all.
And
yes.
even through a telescope like the Anglo-Australian telescope, the biggest telescope in Australia, the one that I use sometimes, you look through that. You don't actually look through it. You put it on a screen. But what you get, points of light. And the reason for that is that stars are very, very far away. They're too far away for conventional telescopes to see them as a disk, because that's what they are. They're actually balls of glowing gas. And so if you had a big enough telescope, you would see them as a disk. Just backtracking a minute, for a minute there, Andrew, what a telescope does do is enhances the amount of light that you see. So whilst they're still points of light, they're brighter points of light. And of course, that means that you can analyze them in different ways with a professional telescope. So what can we do about this? Well, there's not really that much you can do, because in order to see a in order to see a star as a disk, even a relatively big star like Antares, and it is big, I'll tell you how big in a minute, but in order to do that, you would need a telescope with a mirror, and that's the main kind of image forming device in a big telescope. You need one with a mirror about 200 meters in diameter. Now, the biggest telescope in the world today has a mirror rather more than 10 meters in diameter. We're on the brink of a new generation of what are called ELTs, extremely large telescopes, and they will have mirrors more than 20 meters in diameter. The biggest of them actually is going to be 39.3 meters. That's a European telescope that will be in Chile. So that's big, but it's still not big enough to see stars as disks. But there is a trick that you can use, and actually this is beloved of radio astronomers. Radio astronomers do this sort of thing all the time, because it turns out that with radio waves, it's easier to do it than it is with light waves. And that's to make an array of telescopes. So instead of having something, several tens of meters across, you have smaller dishes which you can combine together and synthesize a bigger dish. That's what they commonly do in radio astronomy, but less so in what we call optical astronomy, visible light astronomy, the kind that normal telescopes use. There are technical reasons why it's more difficult, but this technology has not really been exploited as much as it has within the radio astronomy fraternity. So the idea of using an array of smaller telescopes is a difficult thing to do. However, the astronomers and scientists of the European Southern Observatory, ESO, which runs what's effectively the biggest telescope in the world, it's called the VLT, the Very Large Telescope, down there at a place called Cerro Paranal in Chile. That telescope, when it was built, and it's actually 4 separate telescopes that can be combined or used separately. What the people who built it did was recognize that this idea of using an array of telescopes was a possible use for the VLT. And so they built 4 smaller, what are called auxiliary telescopes, that are actually on tracks so they can move around. And the whole thing becomes what in the trade is called an interferometer. And an interferometer is a machine that lets you use the wave properties of light. And light, of course, light waves, we know that's how light comes to us. Those properties include the idea that you can make light waves cancel each other out. So you add two beams of light together and you get darkness, which always seems bizarre to me, but that's
This
what
is
happens.
starting to sound like my darkest days in the maths room.
Yeah, well, there's a bit of maths in it. Yeah, there is a bit of maths. But interferometry is actually a technique. It is a fairly well-established technique, but it hasn't really, I don't think, yet lived up to its full potential, or it hasn't until now. Because what has now happened is that the people at ESO, the European Southern Observatory, have used the VLTI, as it's called, the Very Large Telescope Interferometer, to do these observations of the star Antares. Antares, just to give you a bit of geographical background, is the heart of the Scorpion. It's right there. It's a reddish star, quite bright, sits in the heart of Scorpius the Scorpion. Do you know what its name means, Andrew?
Antares?
Yes, Antares.
No. I've probably heard it, but you know what my brain is like? It's a sieve.
But you mean you don't retain useful information?
Never
like
have.
Why
Never
Antares
have.
is
No.
called? Well, well. Let me tell you, Ares is the Latin name for Mars, the planet Mars, and anything with "ant" in front of it means it's kind of anti or against. And in fact, what the name means is really rival of Mars, and that's because Antares looks a lot like Mars, and it's actually in the part of the sky where Mars passes through, what we call the ecliptic, the path of the planets. So Antares is a Mars-like star in terms of its appearance in our sky. But there is another connection with Mars, and that is that if Antares was where the sun is, right, instead of being 550
let me guess. It would be big enough to touch Mars.
No, actually, Mars will be inside it.
Yeah, right.
You're nearly there. It's bigger than even the orbit of Mars. It's actually, it's bigger diameter than as I said, the orbit of Mars. It would sit between the orbits of Mars and Jupiter.
Wow.
So that's big. It's one of the biggest stars known in terms of its dimensions. To be exact, it is 883 times the diameter of the Sun. It's enormous. But it's also very rarefied because this is a red supergiant star. And I remember reading in an astronomy textbook when I was about 12 that red supergiant stars are nothing more than a red hot vacuum because there's so little material there. They are so tenuous, very, very rarefied material in these stars.
So is this one likely to go supernova in some short period of time, perhaps?
It will eventually. Probably not yet. You know, we might have 1,000 years, we might have 1,000,000 years, but it's not something I can ask you to put in your diary yet because we don't know. But it probably will wind up being a supernova. So what's happened is this big star has now been imaged by the VLTI system. And not only that, but we've actually been able to see detail on the surface.
Wow.
Now, if you can call it a surface, because it's really a fairly rarefied outer envelope that this star has. It's more like a nebula, actually. A nebula is a cloud of gas in space, but it is a star. One of the things we know about stars like this is that they do lose mass to their surroundings. They lose the hydrogen gas that is the fuel of stars. And so the VLTI scientists have done one more thing, which is a really clever trick. They've used what we call the Doppler effect. And the Doppler effect is when you break up the light of a star or a galaxy or a planet into its rainbow colors, you get this barcode of information on its dark lines usually, and their position varies depending on the movement of the star. So if you've got a star that's racing away from you, all these dark lines move towards the red. Sometimes we call it the redshift. That's actually the Doppler effect, though, and that allows you to measure the velocity of things like stars and galaxies and planets, or blobs of gas within the atmosphere of a star like Antares. So these scientists not only have they imaged the surface of Antares, they've also mapped it in terms of the turbulence within the atmosphere of Antares to try and understand why it is losing mass. which stars of this kind do. So a really big breakthrough. I think this is terrific work. I applaud the scientists who've done it. They're actually from one of the Chilean, or the leader is from one of the Chilean universities. So it's very much a South American project. Terrific stuff.
Yeah, it is indeed.
And it's not too hard to find images of Antares on the web.
I've been looking at some as you've been speaking, and an artist's impression of what it might look like with the naked eye.
Close
up.
up, that's right. Yeah,
fascinating. And just to finish up, Fred, this sort of puts astronomers in the same. Now that we can see a disk of a star other than our own, rather than just points of light, it puts astronomers in the same realm as fishermen. I once saw a star this big.
Well, yeah, the problem with stars is, you're quite right, you need to see one this big, because otherwise you don't see it at all.
That's right.
So, yeah, no, it's
All
good
right.
stuff.
More to learn from Antares and probably many other stars in the future, perhaps. You're listening to Space Nuts. Andrew Dunkley here, and of course, Fred Watson.
Space Nuts.
Now, Fred, we'll finish up with a question from our entire audience, that being Rob.
I always thought there's only one person who listens to this.
Well, we're not counting each other, obviously.
Now we know who it is. Rob,
Yes,
well
it's
done.
Rob. Rob Scott from Coolum has written us a note. He says, "Hi guys, if the universe is expanding at an accelerating rate, is it faster than the expansion in the Big Bang? If not, was there some initial rapid Big Bang, as in expansion, followed by a slowdown, then an accelerating expansion that we see today? Tiny mind blown, Rob, Coolum, Queensland." Well, I can't answer that, Rob. So thanks for letting us, know. But Fred, any ideas?
Look, what Rob has said in his question is more or less what an astrophysicist would say. So even if he thinks he's got a tiny mind, he's doing very well.
He's done extremely well.
Because that's more or less what happened. The one thing that is not the case is that the universe is, whilst it is expanding ever more rapidly now, it's still nowhere near as rapidly as it expanded within the first gazillionth of a second. So our model of the way the universe has evolved is that, yes, there was a Big Bang. There was a creation event in which basically radiation, as it then was, came into being with a huge amount of energy. Mm-hmm. But within, and I think the figure is the first 10 to the minus 35 of a second, which, if I remember rightly, will be a 1 with 34 zeros and a decimal point in front of it.
Blimey.
Tiny amount of time. Within that time, there was a phase which we don't really understand why it kicked in, although people are trying to do that, and we don't understand why it stopped. But within that sort of time span, the universe went into a state of what you might call frantic expansion. It went from being the size of a football to the size of a galaxy in about 10 to the minus 35 of a second.
Good grief.
So
it's just hard to contemplate. I mean,
it is.
That's a mega amount of space.
It is, and that was all created within that time. And we call that very brief period when the universe did this frantic expansion, we call it the epoch of inflation, as you might expect, because the universe is inflating. It's nothing to do with the price of things going up. It's the universe getting bigger. And that then settled down to a steady expansion. But so that period of inflation was near the beginning of the universe, 13.8 billion years ago. If you now, so you get this inflation, then it settles down and starts expanding at a slightly more steady rate, a more modest rate. But then about maybe 6 or 7 billion years ago, that's when the universe is about half its present age, it starts expanding more rapidly. And this is the phenomenon that we call dark energy. It's an energy of space itself that is pushing things apart. Now, that dark energy may always have been there, but its effect on the expansion of the universe has only shown up in the last 6 or 7 billion years, because at that time, the normal expansion has carried galaxies further apart so that their gravity is not acting as a brake on the accelerated expansion. So it's like the universe breaking free of this slowdown due to gravity. And the expansion is indeed now accelerating, but it's still nowhere near what the inflationary expansion was. Very briefly, Andrew, just to tell you why astrophysicists think that expansion did take place in the very early history of the universe. It's because when you look at the universe, it's pretty well the same in all directions. The parameters, the physical parameters are the same effectively, apart from the fact there are galaxies and things like that dotted around. It's what we call isotropic. It is more or less exactly the same in all directions. But the universe is very big. And so what it means is that there must have been a time when the universe was basically the size of a football, if I can put it that way.
Yeah.
Then the speed of light was no problem. Things could see each other all over the universe. So everything kind of uniformed out. But when the expansion occurred, it meant that uniformity was preserved in the universe on the wide scale. I'm not telling this story very well.
No, I understand.
But yeah, you need to have the inflation in order to explain this evenness of the universe all around. Otherwise, what you're doing is you're looking at bits of the universe that would have never been in contact with one another.
So to put it simply, if we were looking at our universe from outside, it would be a sphere.
That's more or less, that's exactly what we expect.
Yeah.
And not only would it be a sphere, it would be a pretty uniform sphere as well, with the temperature more or less the same all the way around. And to achieve that, you need this period of inflation. So it was actually proposed back in the 1980s by a scientist by the name of Mr. Guth, or Dr. Guth, Guth. And basically, people have been doing tests on what we can measure on the very large scales to demonstrate that this is actually true. Now, there is no true smoking gun in this, but all the evidence is that the inflationary theory is correct, so that there was this period of rapid inflation, exactly as Rob said in his question.
So there you go, Rob. Hope that satisfies your curiosity, and thanks for sending us your question. And we do invite questions anytime. You can do that through Facebook or Twitter, or I don't know, there's plenty of places you can send questions to us. We welcome them with open minds. Now, one more thing before I let you go, Fred. How was the eclipse? I know you went over to watch it.
Sensational, Andrew. It was a great trip. I was with a tour group. I often lead tour groups like this, and this one was no exception. Although I'm not really the leader, it's somebody else who does all the grown-up stuff of taking us where we've got to go. I just stand and spout about the science and sometimes the history as well. But with the eclipse, it was very easy. So we had a beautiful vantage point on a hilltop in Jackson Hole, Wyoming, and the sky was a bit cloudy at dawn. But by 10:15, when the eclipse started, it was clear. And of course, the moon slowly covers the disk of the sun. At 11:34, that is when it exactly covered the disk of the sun, and the sun's corona was visible. And it was just really spectacular. It was beautiful.
Yes, and you sent me a photo, and it's a classic eclipse photo. It just looks amazing. Nice work, Fred. Well done.
That was just the camera that did all that. I just pointed it at the sky and set the zoom, and away it went.
Well, that's the hard part.
I'm sure it is, yeah. No, it was great. Thank you for asking.
Well, I only have to wait till 2028 to see one in my hometown here.
Yeah, that's right. Yes, I believe the path of totality goes over Shea Dunkley.
Yes, right. We're right in the middle of the path of totality.
So what it means is you'll be able to rent out your house for $3,000 a night, and you'll have parties of people who come and want to stay there.
Sounds good to me.
That's what people do on when they find that they're in the path of an eclipse. They suddenly see dollar signs written everywhere.
Well, it's only 11 years from now. So
that's right.
Yeah, can't wait. All right, Fred, thank you so much. Nice to catch up with you again.
It's a great pleasure, Andrew. Good to talk to you too, and we'll speak again soon.
That's Fred Watson from the Australian Astronomical Observatory. And from me, Andrew Dunkley, thank you as always for listening to our podcast, Space Nuts. You can follow us on Facebook and Twitter, and you can listen to it on just about any podcast platform. And I'd also encourage you to listen to Stuart Gary's Space Time podcast, which is of the same stable. So catch up with Stuart. He does his in a more news style format. We just blabber and carry on like we know what we're talking about. Until next time, thank you again for listening to Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.